for the amount of energy it takes to charge this, we are running that.
Yo, that's good, man.
Just use a computer.
Where's hyperdrive?
Do you want to see it?
Yo, what's good, man?
See ya. How you
Good
been?
to see you.
What's going on?
Been good. I've been hearing a lot from Max.
Max,
What have you been cooking since Zooks?
Since Zooks, well, Hyper's been busy. We have built our own AI that can drive this Tesla with 30 watts of power through San Francisco. You want to see it?
I'm gonna need to see it to believe it.
All right, let's do it. Yeah.
So, where exactly is this AI, man?
The AI? Oh, you mean hyperdrive?
Yeah,
I'd
love to see this hyperdrive thing. Sounds sick.
Okay, check it out. Watch this. And
Wait,
we're engaged. See that green autonomous? That means hyperdrive's driving.
did you hack into the... Okay, how did you do that?
Well, we have our own cameras in this vehicle, so we have a single forward camera here. You can see that there's hot gun glue keeping that in position. We have cameras to the side here looking out, and we have 2 cameras, side repeaters under the mirrors looking back. So that's 5 cameras feeding into a computer in the front, which is also getting air conditioning from the front. And that's running an NVIDIA AGX Orin, which is taking around 33 watts, right? So it takes actually around 12 watts to process the cameras. It takes around 9 watts to run the CPU and the cooling fan on the computer. And then it takes around 12 watts to run the neural network. And your brain, by the way, takes 20 watts. So we are driving this vehicle through San Francisco.
I'd like to have you know, my
12
brain
watts.
takes a lot more than 20 watts.
Yeah, well, with a few Red Bulls, why not, you know?
Okay, so first off, that is insane.
Yeah.
Second off, are you running this entire autonomous driving system just using computer vision?
Just using computer vision.
No funny business, no sensors anywhere.
There's no monkeys in the front. Just a computer like this big.
All right, I gotta say that's pretty impressive. Seems like you're pretty good at this whole like self-driving shtick.
Well, I've been doing it for a while. You know, I first started getting into this area in actually 2011. So seen a few things, built a few things. So you can see here, this arrow just went green. And the map here is telling the vehicle to turn left and do a U-turn, right? I'm not driving the vehicle. We don't have an HD map either. It's actually just getting turn-by-turn navigation, just like you would using Google Maps, right? So it's just driving straight, and if the map says take this turn, the car will just take it, which is pretty much how it works. So you see it's coming up to brake with this vehicle in front of us. Haven't touched anything, all computer vision, driving the vehicle, which is pretty cool.
It's kind of interesting because your origin story started in the film and animation industry. So
Right.
Before it was the computer vision part of things, it was mostly just the camera vision side of things. How did you initially get interested in cameras and sensors?
Well, I think going back to my previous career where I was working in computer animation, it was in sort of 2011-12 that I saw that Google X had a self-driving car program where they had a Lexus driving on a freeway. And I remember reading that article and saying, this is going to change everything. This is not an incremental step. This is going to reboot what mobility means. And for me, with my background in animation, I saw the car becoming a character. It was going to become a robot, right? And so I was like, well, wouldn't it be cool to animate a robot in the real world rather than just digitally on the screen? So that's how I got into looking into the space.
And at what point did you decide that the best application for computers and in some sense these complex graphics is not just the silver screen, but perhaps our actual physical worlds and automating the actual vehicles and robots that we're using?
Right, well, I mean, it's a lot of fun to imagine a character that looks new in a new visual language and make that happen on a screen. I think to make that happen in the real world is much harder, doing it with atoms, but it's also much more rewarding. And so that was kind of the motivation to get into that space, but also, I wanted to make a contribution. So realizing that we're about to transition from the age of the automobile to the age of robotics in 2012, for me that meant that there was going to be a moment in time where the playing field of mobility would be leveled. Personally, I think the power to weight ratio of hyperlabs is probably unmatched on the planet right now, because we actually have this whole system's been created with 4 software engineers, 3 algorithmic architects and 1 infra engineer. We've only been working on it for about 2 years now. As you'll see, it'll drive, a regular robotaxi drive, sort of 15 to 20 minutes without any intervention. We're obviously not perfect, but it's working well under the constraints that we have. We also don't have proper control of the Tesla, right? So we've just tapped into the CAN bus. We've stuck cameras in. We didn't ever calibrate the cameras. The AI just understands how to interpret the vision coming through, and we get glare off the screen and that kind of stuff. But as a pure vision system, it's actually working really well in nominal conditions like today where the weather's good.
A lot of these really complex technical challenges traditionally are the ones that venture capitalists will throw hundreds of millions, sometimes billions. We've recently been seeing literally tens of billions of dollars thrown at some of these really deep technical problems.
Right.
If it's possible to solve them so efficiently and in a very lean fashion, not just from a team standpoint, but also from a technology investment standpoint, why are companies raising these massive rounds?
It's a great question. I mean, we've spent under $1 million getting to this point on this stack. We're not actually building it to build a robotaxi company. We have a novel robot we're applying this to that we're launching next year. And we just did this to prove that the AI could do what we want that particular robot could do, which, like Zoox, is a completely new form factor in a new category, which we're super excited about. But it really comes back to, the philosophy we had with Hyper is really energy efficient systems, data efficient systems. The company has been very thoughtful. We've generated a lot of IP around the process that we're using. It's using some very advanced techniques as well to get the performance that we are. So, for 33 watts of power, driving this vehicle vision only through downtown San Francisco with 1,600 hours of training data, really proud of the team and what they've created.
One of the things that's really cool to me about this is the fact that I feel like I know just how much work goes into creating a local, I'm presuming CNN, or what's the type of neural net that you're using?
Yeah, so it's using a transformer-based architecture. It only has 50 million parameters, which is not a lot. We're running maybe 130 tops on the Orin, which is also not a lot, running 30 watts. So other people are in the multi-100 watts, or they're in the multi-kilowatts. So, a lot of companies are running 2-3 kilowatts of energy, and then they're running that again in cooling in hot environments.
I think there are any other interesting areas beyond driving on public roads where this technology can be applied?
Yeah, absolutely. So this is actually a general architecture. It's not built specifically to drive a Tesla or a robotaxi. We have other products that are robots that we're building that are in different classes and different categories. And it's showing incredible performance in those areas as well. So that's the power of a neural network, is it will adapt itself to a robot based on its data in any kind of function. It's a general system.
Exciting. I can't wait to see what's under the hood.
This is an NVIDIA AGX. That was what's running, about 33 watts. Here we have the camera feeds coming into the AGX. This is a hard drive just logging the camera data. And then this is going into the car's CAN bus, and that is it. And we have some air cooling coming in from the cabin.
I see that was what was connected into there to the AC unit to literally cool the NVIDIA compute.
Yeah, it actually works really well. It's a good use of a front. It's nice and sealed. So with the footwell cooling coming in, the system's super happy.
This is what it was made for.
Yeah, exactly. It's a perfect use for a front.
Super efficient. I'm surprised by this controlling that.
Yeah, it's wild, right? For the amount of energy it takes to charge this, we are running that.
Wild.
Cool.
I'm impressed.
Thank you, my friend.
Fuck yeah.
Cheers. See you next time.
See ya, man.